Good morning, guys. Anjani Kumar here, dealing instrumentation subject for a final year electrical students. Right? In a last session, we started capacitive transducer. Right? So till now, we completed the concept in a passive transducers. We completed successfully what is resistive transducers and different types of resistive transducer, advantages, disadvantages we completed. And after that we completed inductive transducers, different types of inductive transducers and applications that we discussed. And in a last session we started capacitive transducer. Right, I just want to give rewind of last sessions, right? So what is a capacitive transducer, right? We discussed, right? Capacitive transducer means the name itself indicates it's a phenomena. It can find a non-electrical quantity by measuring the change in the capacitance, right? So each and every of my class, definitely there will be 5 to 10 minutes time for rewind the last session, right? So better try to understand, right? So what is a capacitive transducers means? It can measure the non-electrical quantity by measuring the change in the capacitance, right? So how the change in the capacitance that we discussed in the last session, you know the formula for capacitor, there will be a two parallel plates and dielectric medium will be placed there, right? So when you apply a voltage, the charge will be accumulated, right? How much charge is accumulated means that much capacity of the system, right? So what is the formula? Epsilon A by D. So epsilon we can call it as a permeability, and A is nothing but area of the plates, right? This is the area of the plates, and D is the distance between the plates, right? So how the capacitance will be changed? You can change the what you call the cross-sectional area of a plates. Your capacitance will change. If you change your permeability, your capacitance will change. If you change the distance between the plates, your capacitance will change. So how these are the non-electrical quantities. So you can make the change in capacitance you will get. If you change this non-electrical quantity, then the capacitance will change. So you can measure these capacitance by a standard meter or electrical meter or a voltmeter, standard meter, Wheatstone bridge meter, or else whatever it may be. So you can measure that change in capacitance with the help of that standard meter. So result that what you get will be the analogous to the what the area or a distance or a permeability, right? Dielectric permeability or what these non-electrical quantities which is converted to corresponding electrical quantity. That's it, right? So how the capacitance will change means, so we discussed about how the capacitance will be changed. There are three parts: by changing the cross-sectional area, right? And the second one is by changing the dielectric material, right? So by changing the distance between the two plates, that is called DD, right? These are the three things that we need to make your capacitance will change, right? If you change these things, your capacitance will change. Corresponding change capacitance you will measure, right? So by changing the cross-sectional area means how it will be. By changing the cross-sectional area means, so there are two parallel plates, right? We are placing here. So these are the two parallel plates. This is a common area, right? So this is the common area. This is the breadth and this is the length, right? What is the area? Area is nothing but L into X. So if you apply a displacement by changing the area, changing the displacement, that means you are changing. This is a common area. How much area? That much capacitance will be developed, right? So if you apply a displacement, your area will be changed, right? The displacement changes means your capacitance also changes. See, C is equal to epsilon A by D now. So epsilon, what is A value? L into X now, right? Epsilon is a constant. Length is length between the plates is a constant. Length across the constant. Distance is a constant. You are varying your displacement, your capacitance will change. Now you apply your displacement. So what happens? Your X value will be changed. If X value changes, the capacitance will change. So you can find the change in capacitance by a standard meter. So voltmeter or ammeter, whatever it may be. right? So whatever the voltage that you get, that is analogous to the applied displacement. So in this way we can calculate the displacement, that is a non-electrical quantity which is converted to electrical quantity. So that is nothing but a capacitive transducer, right? So what is the sensitivity? If you want, why we can calculate the sensitivity means this transducer is nothing but an instrument now. So you will check whether the instrument which will use a linear scale or a non-linear scale, that you need to find out. So for this you need to find out the sensitivity. So what is the sensitivity? Out there, change in output by change in input. So what is the output? Change in output is DC, change in input is dx. Epsilon naught epsilon L by D. So if you differentiate, x plus k mutudi epsilon L by D. So dc by dx is equal to a constant. So dc is directly proportional to dx. So output is directly proportional to input. Then the scale is a linear scale. Right. So these are the things that we discussed in a last session. I hope I completed by changing the dielectric material also. I'll discuss, no problem, right? So everyone should understand the subject, that's it. By changing the dielectric material, for suppose if this is air is a dielectric material, you applied a voltage, right? So air is a dielectric material, so you have the capacitance value C, right? That is equal to 10 microfarad, right? You are changing your dielectric material. So this is an air. We are placing a liquid, another dielectric material called a liquid, right? You are applying your voltage. So definitely what happened, the capacitance will change because the electric material will be changed. Here we will get somewhat capacitance. This dielectric material will get somewhat capacitance. So the total capacitance will be C1 plus C2. So initially the capacitance is C. Now the capacitance will be C1 plus C2. Definitely the change in capacitance will be there. So for suppose if it is a 10 microfarad, now we'll get a 50 microfarad. So how you get the 50 microfarad? By changing the dielectric strength. So you can find the value, find the change in capacitance with the help of a standard meter. So you can convert it to voltage or current. So whatever the voltage that you are getting in output, which is analogous to change in a dielectric material. So that's why this is nothing but by changing the dielectric material. So you can get change in capacitance also. Now we'll discuss about change in the distance value, right? If you change in the distance also, your capacitance will be changed, right? So these two are the plates, right? You are applying a voltage, right? The charge will be accumulated here. So this is the distance. When this much distance for the capacitance is C, now you are increasing your distance. You are applying voltage. So what happened? Definitely the capacitance will reduces because C is equal to epsilon A by D now. C is inversely proportional to the distance. If distance increases, your capacitance will be reduces. If it is a 10 microfarad, if you change the distance between the two plates, you will get 8 microfarad. Right? Change in capacitance. How you can get the change in capacitance? By changing the distance. So whatever the distance which is analogous to change in capacitance, right? So whatever the change in capacitance, you can measure by the help of voltmeter and ammeter na. So whatever the output that coming out from the voltmeter and ammeter, which is analogous to the distance that you are applied. So that means non-electrical quantity distance which is converted to voltage. Right? What about the scale here? The scale we are getting C is equal to epsilon A by T. Right? What is the sensitivity? DC is my output. So what is my input? Change in distance, right? So epsilon A by D. So 1 by D minus 1 by D square na. Epsilon A by D square. So how the scale you are getting? You are getting a scale is a non-linear scale. See, DC by DD is equal to minus K times 1 by D square. That means DC is equal to minus K by D square into dx. So this is somewhat non-linear scale, not getting a linear scale. I don't know how the scale will be, right? If it is DC, if it is D6, the scale is a non-linear scale, right? So in this way, but you will find that whether the instrument, whether the transducer is nothing but an instrument, how it will shows. It will show a linear characteristics or a non-linear characteristics that you need to find out, right? So these are the methods. These are the methods that can use it to change the capacitance, right? Now In today's session, we will discuss about. So the scale is a non-linear. By changing the distance, you will get the scale is a non-linear scale. So why can't we get that scale is a linear? So we have a differential capacitive transducer here with me. So with this we can make that scale is a linear scale, right? How it will be, we'll see. So up to that is enough, but I just want to make that scale is a linear scale. Then it will be used for other instruments also, other working purpose also, right? How you can make that scale is a linear scale? So with the help of a component called, with our system we can call it as a differential capacitive transducer, right? Simple concept. Differential capacitive transducers, right? So by changing the area you will get the linear scale. By changing the dielectric material you will get the linear scale. By changing the displacement, by changing the distance between the plates you will get the non-linear scale, right? By changing the area, you will get the linear scale, right? By changing the dielectric material, you will get the linear scale, right? By changing the distance between the plates, you will get the non-linear scale, right? The purpose of differential capacitive transducer is to make the change in the distance between the plates, and it should make the scale is a linear scale, right? Initially by changing the distance between the plate you will get a non-linear scale. Alright, so differential capacitive transducer, it can be used to make the scale is a linear scale. Now we'll see how the arrangement will be. Alright, we'll see the construction of a differential capacitive transducer. Right, so the construction is a simple. Right, so ultimate aim is to make the scale is a linear scale. How it will be? So definitely we are having a two plates, right? You are applying a voltage here, right? So this is another plate which is called a movable plate. So these are fixed plate, right? So these are fixed plate and this is a movable plate. So now you are applied a voltage E, right? Now so there will be a dielectric medium. Air is a dielectric medium. Here also air is a dielectric medium, right? The displacement, the position which we can call it as initially x is equal to 0 position. Now you are moving your movable plates up and down only, right? So the distance between the two plates we can call it as a d, whatever it may be. The distance between the two plates we can call it as a d, or else so whatever it may be, the distance between the two plates we can call it as a d, right? It's like now the position of a moving plate at a 0 position, right? That's what we are not moving the plates, right? There will be a capacitance exist now. So between this is also two plates now, there will be a capacitance exist now. This is also two plates now, there will be a capacitance exist now. So we can call it as a C1 and C2, right? You know that how the capacitance will be placed like this, right? You are applying the voltage E, right? So this is called E C1 C2. So what is the voltage across C1? We can call it as a V1. voltage across V2, we can call it as a C2. The voltage across C2 is a V2. You know the voltage divider rule. What is the formula for V1? V1 is equal to E into C2 by C1 plus C2. You know the formulas, right? So V2 is equal to E into C1 by C1 plus C2, right? Now your position is at 0 position, right? There will be a capacitance will form. So what is that capacitance? C1, C2, right? So now you are finding the voltage across the capacitance. So what is the voltage across the capacitance? V1 is equal to E into C2 by C1 plus C2. V2 is equal to E into C1 by C1 plus C2. Alright. Now the position of our displacement is 0. Alright. I hope it's clear from now you will see at x is equal to 0 position, what is delta E? You know that it is nothing but a differential capacitive transducer na? So the voltages are changes, that is nothing but E1 minus E2, right? Now E1 minus E2. So whatever the x is 0 position, that means we are not changing your voltage, right? The same voltages that will appear across the voltage across the C1 and C2, right? You are not moving your position, right? At position x is equal to 0, E1 equal to E2 now. So whatever the voltage across C1, which is equal to the voltage across C2. So what is delta E? Change in voltage is nothing but 0. Now what you are doing is, it's a differential capacitive transducer. So that's why I'm taking voltage difference, right? That's it. Nothing is there, right? So initially we are not placing, we are not moving anything. So that means the position is a constant, right? Position is a 0 position. So whatever the voltage across C1 is equal to voltage across C2. Two identical capacitance that we are taking, right? So the net voltage we can call it as a 0, right? Now you are moving a position at x position. Now you are moving a plate at x position. So you are moving the plate at x position, right? So you are moving the plate. So x plate lo you should move upwards or downwards, whatever it may be. And then upwards move chesna. So what is the value of capacitance C1? C1, C2 will be changing now. You will get the change in capacitance now. Okay. Initially at x is equal to 0 position, there is no change in the capacitance. There is no change in the capacitance means there is no change in the voltage. That means the difference in the voltage is a 0. Alright. Now you are moving your plates. So moving your plates means movable plates ni move chesa. X distance lo move chesa. Now what is a C1? You know the formula. Epsilon A by D minus X na. Right. So epsilon A by the total distance is a D. Right. So C1 is nothing but D lo nunchi X tise you will get the C1 value. So this we can call it C1. This we can call it as C2. Now the capacitance are changes. So what is the value of C1? Epsilon A by D minus X. The distance is D minus X. So what is the C2 value? What is the C2 value? Epsilon A by D plus X. Right. Now the capacitance and changes. Right. Your displacement which is converted to change in capacitance. Right. How you can measure the change in capacitance? You need to find out the voltages. Right. So the C1 across the voltage you are assuming that E1, E2, right? Now the delta E, now the voltages are different now because the displacement changes. Your voltage is not equal to make the 0. So you shouldn't make voltages are 0. You should make E1 minus E2. If you calculate it, you will get the value of X by D into E. Right? So that means you are getting that. Right? That means you are getting what is your output? Change in capacitance. What is the input? Your input is nothing but a displacement dc by dx. You will get the value of E by D na. E by D, x value 1 na. X is nothing but 1 na. Right? The change in capacitance is directly proportional to displacement. So how the change in capacitance is my output? So what is the distance between the plates? It is not a displacement. It's a distance between the plate. X is nothing but you are varying the distance. right? So you are varying the distance, you will get the output voltage x by d into E. See here, x is nothing but distance variations, right? A dc is directly proportional to dx. Whatever the output, this is output. What is the input? A distance variation. Output, which is linear variations with input. Now the scale is a linear relationship, right? Linear relation. So this is the equipment, this is the experiment which can use it to make the distance between the plates, to make the capacitive transducer while distance varying. It can make this type of experiment will make the scale is a linear scale. So that's what nothing is that. I'll explain one more time. So basically ఏం జరుగుతుంది, డిస్టెన్స్ని వేరీ చేసినప్పుడు you are not getting the scale is a linear scale. So how you can get, definitely you require a linear scale, right? Direct accurate measurement you will get with the help of linear scale. How you can get the linear scale? You have a differential capacitive transducer equipment to make a change in distance transducer which can make a linear scale. How the experimental look like is nothing but a two fixed plates and one movable plates. Externally you are applying the voltage, right? So initially the positions are at zero position. I am not changing the position, right? So is there any capacitance changes? There is no capacitance changes. There is no capacitance changes means whatever the voltage or a constant na. So it is a differential capacitive transducer na. So what about the change in change in voltages? E1 minus E2. So what is the change in voltage? Delta E is equal to 0. Now you are not changing your capacitance, not changing your voltage. Whatever the delta E is equal to 0. Right, now you are moving the position, right? Distance ni vary చేస్తున్నావు. Now the distance movable plates లో x distance ను vary చేశా. vary చేసినప్పుడు C1 C2 మారిపోతాయా? సో దాంట్లో అక్రాస్ గా వోల్టేజ్ కూడా మారిపోతాయా? So that's what I am trying to say. You are varying a distance, your capacitance also changes. How the capacitance changes? You are applying a change in distance. Okay, my problem is over. Now I am changing the distance, the capacitance C1, you will see the C1 is equal to total D minus X, you will get the C1 value, right? C2, E epsilon A by dx. Now you apply changing distance, changing voltage means whatever E1 minus U2, you will get the value of X by D into E, right? Okay, if you solve, we don't have any that solution with this. Similarly, whatever this, with the help of these two, you have to analyze this one. Now here, what is the voltage? What is the output? Yes, definitely change in voltage. How you get the change in voltage? By changing the capacitance. DC by dx is nothing but changing the distance. So that is equal to x by d into E, right? So if you differentiate with respect to d, with respect to x is nothing but a distance. That is a distance, not the displacement, right? You will get the dc is directly proportional to dx. X is nothing but a distance ni vary chestunna. You will get the capacitance is a linear relationship. So definitely at last you will get the linear scale. It's very very important. A few years back you got this type of question in your board exams. That's why I have taken this one, right? And one more thing is there. So that one is, if you consider the two parallel plates, right, rectangular plates, right? If these two are rectangular plates, you will define the capacitance value. C is equal to epsilon A by D, right? The smallest change in the displacement, it is very difficult to find out these type of rectangular plates, right? For a small change in the displacement, for a minute change in the displacement, it's very difficult to change in the capacitance. So for this we go for a circular arrangement, right? How it will be means, this is one type of circular arrangement, right? This is another circular plate. These are two plates. The diameter is D2. Here the diameter is D1, right? So we can call it as a distance. We can call it as a this we can call it as a capacitance, right? This we can call it as a distance between the plates, right? So these type of circular arrangement that can be used for a minute change in the displacement. right? For a rectangular plates, it can be very efficient method for finding the change in the displacement, but small change in the displacement, it's very difficult to identify. In that cases, we just go for a circular arrangement. We have two circular plates which are separated by the air. Air is nothing but here. Air is a dielectric medium, so there will be a capacitance form. So total distance will be there, right? Nothing is there. So here, what is the formula? You know that formula: 2 pi epsilon log d2 by d1. This is the formula for capacitance. Epsilon x. So epsilon a is nothing but L into x, whatever it may be, right? 2 pi epsilon a log d2 by d1, right? So whatever the displacement you are applied, the strain, that is nothing but force, that is nothing but displacement. When you apply it, this plate will move, right? That means x value changes, right? L values, this is nothing but L. So this we can call it as x, right? Length and breadth, right? So when you apply a displacement, this x value will be changed. Here the a is nothing but L into x. That's what I wrote. This is the x L value, this is the x value, right? When you apply a displacement, what happened? This x value will be changed. X value will vary. So this cylinder will move upwards, right? X value change. If x value change, the change in capacitance will be present now. The change in capacitance you can find with the help of meters. So that voltage, whatever the voltage or current that coming out from that change in capacitance, which is analogous to the displacement that you applied. Right? This is one of the simple concept circular arrangement that can be used to find the smallest change in the displacement, very minute change in the displacement that can find with the help of circular arrangement of capacitive transducer concept. Right? I hope it's clear. These are the different types of different methods or different types of capacitive transducers that we need to find the non-electrical quantity, right? So that till now what we discussed about the capacitive transducer. So by changing the cross-sectional area, by changing the dielectric material, by changing the distance, and after that by changing the distance you are getting a non-linear scale. How you can calculate, how you can find these non-linear scale into linear scale? By making the arrangement called differential capacitive transducer. Right, so I clearly explained how the differential capacitive transducer will work and how you will get the linear scale and all these things. After that, for a minute change, definitely the rectangular plates that can be used for find out the displacement. For a minute displacement, we just go for a circular arrangement type of plates that can be used to find the change in capacitance. So these are the things that we discussed till now, under the concept of capacitive transducer. Now we'll discuss about what are the advantages and disadvantages and applications that we need to discuss here. Simple, nothing that much advantages and all these things. Now, very important concepts. Capacitive transducers are very important, right? Advantages of capacitive transducer. Right? Just now I explained it is used for minute change in the displacement. Smallest change in the displacement. Right? The first advantage is the smallest change in the displacement. So these type of transducers are more sensitive. Right? These type of transducers are more sensitive. Right? In this type of transducer, you will have a frequency component, right? XC. Right? So this component will use it to find the frequency response analysis. Frequency response systems. Right? So the frequency response systems, these type of capacitive transducers that can be used, right? These type of capacitive transducer are having high input impedance. High input impedance, so definitely the loading effect is less. Less loading effect, right? And after that, so these type of capacitive transducer which is having a high input impedance, so that means the loading effect is very less. And after that, so whatever the output, the power consumption for getting the output is very less. Power consumption for getting the output is less. So these are the advantages of the capacitive transducer. The first one is this minute change in the displacement that we can easily find out with the help of this type of capacitive transducer. And these type of capacitive transducers are more sensitive. And after that, here we have the component of frequency that definitely we can very successfully. Definitely we can use these type of transducer for frequency response analysis systems. So better than inductive transducer, right? And after that, these type of capacitive transducer which is having high input impedance, so that's why it can be used for less loading effect. Loading effect means high input impedance and low output impedance. So that means high input impedance is this type of instruments are having high input impedance means definitely the loading effect is very less. And after that, the power consumption, right? For getting the output, the power consumption for these type of capacitive transducers are very less, right? So these are the advantages of capacitive transducers. Now we'll discuss about disadvantages of capacitive transducers. Disadvantages of right. The first disadvantages. So we should provide proper insulation between the plates. Proper insulation. Right. So between the plates we should provide proper insulation. Otherwise, definitely there will be a dead damage between the two plates. Right. The first disadvantages. And the second one is, so the capacitor, so which is connected, the capacitor box, this is a capacitor transducer box, now it's properly earthed, right? It's properly earthed. Otherwise, definitely the severe electric shock, stray magnetic fields are going to be developed, and this will get damaged that capacitance in the capacitor transducer. So definitely the box will be properly earthed. All right. So after that, and third disadvantages is, so due to the capacitive transducer, definitely the cables which are connected to the capacitor transducer, there will be create some error. The cables so connected will create some error. Right, these are the disadvantages with the help of while using the capacitive transducer. That means while you applying a different displacement or a distance, we require more force requirement. Right. So these are the disadvantages of capacitive transducers. So first one is a proper insulation we should maintain, and the second one is all the case should be properly earthed, otherwise a stray magnetic field developed and definitely the capacitance will get damaged. And the third one is the cables which are connected to the capacitive transducer will create an error. And after that, it can be required a more force to move the displacement or a distance variations, right? So these are the disadvantages that that are present in the capacitive transducer. What are the advantages? The smallest change in the displacement we can measure, and more sensitive. It can be used for frequency response, and it is having a high input impedance, so that means the loading effect is less. And after that, the power consumption for getting the output is very less. So these are the advantages. And what is the disadvantages? As a proper insulation we should maintain, and the case which is clearly, otherwise the capacitance will get damaged. That means due to the stray magnetic fields will develop in the system, definitely the capacitance will get damaged, and the cables which are connected to the capacitive transducers will get will make an error, and definitely we require a more force, right? And the final concept, which is that is nothing but applications, right? We'll discuss about the applications, right? Right, you will tell all the applications, right? It is used for displacement measurements, and the second one is used for the force pressure measurements, right? So force and pressure measurement, so it can be used to find out the humidity in the gases, right? It is used to find out the humidity in the gas. It can be used for find out the weight, dielectricity, right? All these things, right? So these are enough. What are the application? So the displacement measurements, and after that force and pressure measurement, mechanical calculations, right? Mechanical measurements, right? And humidity in the gases itself, and after that the weight and dielectric constant. So these are the applications for finding the capacitive transducers, right? So this is about all the information regarding capacitive transducer, right? These concepts more than enough for your end exams, right? Thank you for now. In the next class we'll discuss about LVDT, very important concept. So definitely all the concept in this unit are very most important for your end exams, for your gate, IES oriented also. So better try to understand the concept, right? In the next session we discussed about LVDT, right? After that strain gauge, after that some few concept like thermocouple, thermistor, piezoelectric device. There are simple concepts, right? We will clearly explain. So with that we will finish, right? It will take around at least 1 week time to finish this unit, right? Thank you very much.